All right. You want to start on the first one, Rich? We'll give them maybe 2 minutes to work this one out. Please try your hardest to work it out before we go over the answer, okay?
A couple of different ways to do this.
There's one, the best way to do it.
I know you're gonna use that way, which isn't my way.
Well, you tell me what your way is.
I use the double, if you know what I mean. Find one variable using one
No.
and use the thing with the other.
No, don't do it that way.
Or you could also do it
The
osmotic pressure sort of similar.
or this way, right here, the easiest way to do it. I would probably just teach it this. Go to teach them efficiency.
Little CGL.
That's it.
Later.
See ya, have a good one. Yep. You know that plastic is bad for the environment.
Give this candy. Put all the plastic in there. And you make some candy.
All right, end time.
All right, so how did y'all do this? What equation did you use?
Hold on. Oh, is it the combined test?
Combined gas.
Okay,
Did you do the problem?
No, but I saw because it has liters and a Kelvin and
just look at my.
Yeah.
Alright, so.
Yes,
P1,
this is a
P1.
Loving zone. Okay.
Equals P2, P2 over T2. So our P1, we have torque, does that matter?
yes.
So you convert it, you leave it,
We can learn how it is.
all right,
We heard two different answers.
Aren't you allowed to leave it? The only thing you have to change is Celsius to Kelvin, but it's already in Kelvin.
Let me ask you, every time you see, I'm gonna tell you, every time you see the letter R, that's in units that have atmospheres. If you don't see R in an equation, you don't need to convert to atmospheres.
so no R,
So you always-
no ATM.
That could stay as torque.
This can stay as torque,
Oh.
yeah. Because there's no R, which one of the requirements for R is that your units have to be in liters, atmospheres, and Kelvin. In this case, R is not in there, so it doesn't matter.
You can use whatever you please, as long as your units stay the same.
Yeah.
So what we're gonna go ahead and do is, our P1 is gonna be 745. Tor, I was leaving like that. V1, 3.65 liters. 3.65 liters over our T1, which is, let's be a bit different here, and it's given in Kelvin, so we can do 298. And set this P2, so we have 367 times our V2, which is what we're solving for, and our T2, which one of them is Celsius, one of them is Kelvin, so we have to convert this one to Kelvin, so 273 minus 14. I know it's technically 273.15, but I use 273 because it's faster. So you get 259 Kelvin. All right, Now it's just a matter of doing your cross multiplication and solving for the variable you're looking for. So when you plug all this into a calculator, what did y'all get? Go ahead and plug it in real fast. Use your algebraic knowledge, strength, and integrity.
And that's Sophie. So you can do like one step at a time, so you can do like the left side first. So you can do like 745 times 3.65, get your answer. Divided by 298. Yeah,
So you could do divided by 298 times 367 as your second step, and then you should get an answer. All right, Sophie got 6.44 liters. You all agree with that? All right.
Yeah.
The room people agree, the Zoom people agree, the motion is passed. 6.44 liters is the correct answer. All right, you have any questions on that? You have a full idea of how I got to that problem?
good job, Sydney.
All right, so was there another way I could have done this problem? The combined gas law is the easiest way, but there's actually another way. In case you didn't see that from the get-go. So you have a pressure, a volume, and a temperature, right? Those are the only things that are changing. Your number of moles in this case are being held constant. So what you can do is do the ideal gas law, PV equals nRT, solve for your moles real quick. So PV over RT, then using these numbers. And then what you can do is take your moles you got here and plug it into a new PV equals nRT equation and solve for your volume.
But this is super long
Yeah.
because you have to convert your pressures to atmospheres and then plug it in and make sure all your stuff, like all the units have to match up. It's
So the best way we did it is easy.
the best way to do it.
Yeah.
I would not even consider that second way, but it's true. There's multiple ways to solve these problems, not just one way. The best, there's always a best way though. And in this case, using combined gas law gets you there pretty quick without having to, you know, find one variable, plug it into another one, make sure units match up on each one. It's just a more opportunity for mistake, and you want to prevent mistakes on our exams.
Okay. So let's try out number 22.
Sydney asked you a question.
All right. Would you recommend memorizing the gas laws of this one equation PV and nRT? I would say if you're more, like, it depends, right? If you're more comfortable with math, just go with the PV equals nRT one, because the idea is you can derive all of them from just using PV equals nRT. Like, for example, let's do Boyle's law. That's P1 V1 equals P2 V2. The only thing that's changing in your equation are pressure and volume. So you can disregard this whole left side and just put P1 V1 equals P2 V2. But if you're not much of a math person, just go ahead and memorize all of them.
But it's important to know the names of each one, so I would just go ahead and say memorize them all and their names, because you may get asked which of the gas laws corresponds to this graph or something, and you have to know the names of each one and the variables associated with each one.
So let's go over those real quick. So P1 V1 equals P2 V2. That's Boyle's law. Boyle's law. Then we have V1 over T1 equals V2 over T2. Whose law is that?
Without looking at your notes. Starts with a C.
Charles.
Charles.
Law.
Yeah.
Right? My personal favorite, P1 over T1 equals P2 over T2. Who did that? Gay-Lussac. Exactly. So this is gay.
And
So,
that's like memorize which is with which.
What?
What do you think is the best way to like memorize which?
Just like flashcards, probably. It's only like 5 gas laws, so there's like 5, make a couple index cards, and when you're walking to your next class, pull them out. Okay, that is quiz yourself. Or a Quizlet, you know, whatever you want.
or you can make like acronyms, like when you boil stuff, you increase the pressure and volume. Yeah, you could do something like that. And then it's whatever works for you. Then there's this one, V1 over N1 equals V2 over N2. Whose law is that? Avogadro's law, exactly. Whatever you see in moles, think of Avogadro, because Avogadro's number 6.022 times 10 to the 23rd. And then you have this one, P1 V1 over T1 equals P2 V2 over T2. That's your combined gas law. I'm just going to abbreviate that as CGL, combined gas law. And yeah, technically sometimes there'll be an N1 in that equation too. That also counts. Yeah, I've seen it both ways. So it could be like this, or you could have P1, or really if everything's changing, then you'll just use your regular equation, PV equals nRT.
That's the ideal gas equation.
So ideal gas law.
I can do the next problem. All right, go ahead and try number 22. Give y'all 3 minutes starting now. Set a timer for 3 minutes.
3 minutes, counting down.
One minute. Hopefully you're starting to finish your calculations or starting to input it in your calculator by now. If not, that's okay. Twenty seconds. And time. All right. Anyone able to finish it? No? Get an answer? No? How far did you get?
I was just trying to set it up and I got confused.
What confused you?
What was with what?
Wait, what?
Like what was with what, like the formula it gives us.
Okay, I see. So when you,
Like setting it up, I guess.
okay, so can you, I guess the first important thing is identify on a test that this is asking you to use gas laws, right? Why? Well, that's for pressure, right? So that's clearly got to be about a gas.
And then if you look at the periodic table, argon is noble gas. So you'd have to use something with gas laws.
Yeah. So it's also asking, it also has this variable of moles. What are the equations that we just went over that involve moles? So V over N equals V over N, and what else? Yeah, ideal gas law, so PV equals nRT. All right, so clearly, we're also given quite a bit of information about other stuff. So we're given them information about the volume and the temperature. So, and we're asked to find pressure. So there's one clear winner on which equation we should use, right? Because there's only Avogadro's doesn't utilize pressure. So how are we going to solve pressure if we don't have either of these? And also, it's not changing. It's not like the system is changing, in which case you would use V1, N1 over V1 or V2, N2, right? Something like that. So clearly we need to use PV equals nRT, and we're solving for pressure. So let's erase this part. So we want to solve for pressure, and we just divide both sides by V, and we'll get P equals nRT over V. And from here, we can go ahead and plug everything in that we need. But one thing that I noticed, or two things I noticed, is that our units need to be in what? So liters, this should be in liters, this should be in Kelvin, and moles is fine. Okay, so this is converted to liters is 0.075 liters. This is going to be 26. So 26 plus 273.15 equals the number of 299.15 Kelvin. So this is our T. This is our V. From here, it's just plugging it into our formula and then putting it into our calculator. So we have 1.47 times 10 to the minus 3 moles of AR and 0.0821 liters atmospheres mole Kelvin. And then our temperature was 299.15 Kelvin. All over our volume, which was 0.075 liters. As you see, our units cancel out, so this moles cancels that, liters cancels that, and Kelvin cancels with that Kelvin. Okay, so you're left with units of atmospheres. Putting this into your calculator, you should get an answer of about 0.48138 atmospheres, which is nice and all, but it's asking for the pressure on what unit? Torr. Thank you, Sydney.
So how many atmospheres equals a torr or vice versa? I mean, torr equals that. Yeah.
So 1 ATM is 760 torr.
What is that also the same as? 760 torr equals 760 what unit? Millimeters of mercury.
Exactly. So after plugging this into our calculator, we get 365. And should be 366, so 365.8. Which goes to 366 torr. So I hope if you got stuck during this problem, I hope you realize where you messed up or where your thought process was incorrect. And you should be able to try to reason through another problem later. So if you don't know where to start, at least try to find out an equation that makes sense to use. We said the only gas equations that have moles is going to be your Avogadro's and your ideal gas law. It only makes sense to use the ideal gas law. So from there, it's straight up just plugging in, finding P, and then converting your units of pressure. So that's what we're trying to get everyone to a point that they can see that when they need to. All right. Number 23.
Right, I'll do this one because Michael Jordan's go.
Why? What does Michael Jordan have to do with it?
Number 23.
This guy. What about Draymond Green?
Used to go to the other things. Namely kicking people in a certain region. Of their body.
That is true. We give you all 2.5 minutes. Starting now. Start a timer for 2 minutes and 30 seconds and 40 milliseconds.
2 minutes and 30 seconds. Counting down.
Okay, she doesn't do the 1 milliseconds. Great. Okay, tapping my pencil until it breaks.
That's still a nice foot gesture thing.
Yeah, you don't have that? Oh, that's great. I'll say I'll use it. Cause you have to, cause like doing this, or I guess it's makes sense, but when you're doing this, I write like this, so it's kind of weird to like have. And just write like, I mean, it works, but I like take my fingers out. I rather just usually just click on it.
Just put it on the flat side and do that.
Yeah, I guess. Are you gonna derive the equation from scratch again?
Yeah. Oh,
Try to write extremely neat and small, so you don't take up the whole. That pencil thickness is the same size here. So. Maybe if you write smaller, your handwriting would be naturally neater.
how is small?
Bro.
That's
Sorry.
probably like 12.5. This is like 14. Wait.
So I got to see a girl yesterday.
I saw that.
Let's see, how much time we got left? 25 seconds.
30 seconds. $15.
You know, you know.
Yeah. And time. Okay. So what is the density of xenon at stoop? What is a stoop? What does that mean?
What?
This isn't called stoop, it's standard temperature and pressure, STP. Standard temp. and Pressure, or yeah, standard temperature pressure. So what is this equal to? 1 ATM, and what else?
273.15.
So 273 Kelvin. 1 atmosphere is 0 degrees Celsius. So the density of xenon. All right, so what's the formula again for density of a gas? Well, we're not given any mass or any volume, so how are we supposed to do it?
What? Go through our camera roll. Equals
Pressure times
smaller mass over RT. Exact. Perfect.
So the density equals pressure times molar mass over RT. But in case you forgot, let's see how we get. it. So obviously we know this, PV equals nRT. And we need to get to density. Density, as the person with the Kakashi at the back phone case has stated, is mass over volume. So what we can do is we need to make our equation equal to mass over volume. And a way to do that is to first of all get mass in there. So what is moles also equal to? Like whenever we get moles, like how do we convert from like grams to moles?
Avogadro's number.
That's atoms.
Yeah, from like, say you have like grams or something, how do you get to moles?
So like stoichiometry.
Yeah, the molar mass. That's to get moles, you divide by the molar mass. So to do that, it's your mass over your molar mass. So you rewrite the equation, pressure times volume equals mass RT over molar mass. So then, right, it's just a matter of rearranging the equation to get mass over volume. So we can do a cool magic trick. We multiply both sides by the molar mass. So we get pressure times molar mass times V, molar mass times V equals RT, or MRT, sorry, MRT. And then what we can do is divide both sides by our RT, one term together. So we get, this cancels, we get pressure times volume times molar mass over RT equals just your mass. Now, for the final piece de resistance, we're going to divide both sides by our volume. So this cancels and we get mass over volume equals pressure times molar mass over RT. To avoid doing this on the exam, just go ahead and memorize this guy right here. That's how you get from here to here. All right, so we're gonna this. So density of the xenon at STP. So pressure, right, we know is 1 atmosphere. So density is gonna equal 1 atmosphere times our molar mass of xenon, which if you look on your periodic table is 131.284 grams per mole.
It's 294.
294.
I'm trying to do the trick.
294 over R, which is the same R we've been using, 0.0821. And our temperature is 273 Kelvin, because that's what standard temperature and pressure is. So if we solve that out in your calculator, you should get 5.85 grams per liter as your density. 5.9. Round, if you round. However, I did not round.
Oh,
Interesting.
6 makes this 5.9. All right, I can do this.
All right.
So I hope if you were here yesterday, yeah, you did a problem just like this yesterday, I believe. So I hope you were able to do that one. If not, there's plenty of more attempts at similar problems. Anyways, go ahead and try number 24.
Actually, another way to do this. So you take that number. Do the thing with that number. Take that times that. And divide by that. Should work.
Take this number. Multiply it by that to get grams. Oh yeah, because you get mass and divide by volume.
Yep.
Let's see if you can see the same thing. This work. Thirty seconds. But is that not enough time?
No.
But this is roughly like the amount of time you should be spending on the question on a test. That's why I go at this pace.
It's different because you can go through the whole test and answer everything you automatic. And you'll have way more time to work on everything you don't know.
Wait, what?
You can go, like, you can answer all the questions you know off the top of your head. Like. it comes
Well,
to
they're
you
multiple
quick.
choice.
And they're also math problems, so there's no way you can know the answer like right off the top.
Yeah.
Yeah, but like I'm saying, like, you know the equation, you know the steps off the top of your head. And then you have everything, you can answer everything else afterwards that you don't know off the top of your head. And then you have way more time.
But assuming you spend equal amounts of time on a question.
Well, that's not true.
All right, end time. What was the equation y'all started using when you solved this problem? Yeah, perfect. PV equals nRT. And we know it's PV equals nRT because it's asking about how many moles, right? And so we're left with Avogadro's law or ideal gas law. And clearly, if we use Avogadro's law, we can't use pressure or volume and we're given volume. And we're told that it's at standard temperature and pressure. So it's important to realize which equation you should be using. So PV equals nRT. To rearrange for the moles is solve for n, right? So it's going to be n equals PV over RT, which plugging in everything we have, we know this equates to 1 atmosphere and 273 Kelvin. So we plug in everything there. So 1 atmosphere times the volume, which it gives us. So 0.04 liters. And we have R 0.0821 and 273 Kelvin. Were y'all able to get this far at least? Yeah, and what did y'all get when you put this in the calculator? You didn't put it in the calculator? What?
Why not?
It's too small.
It's too small. What's too small? Okay, so
Oh, never mind. She got it.
Sydney got 0.0018. That is pretty much what I got. When I did it, I got 0.00178. I just didn't round for interesting purposes.
Remember, no number is too big or too small. With Armand's problems, he'll give you like 10 to the negative 21, pretty small number. And then for our exam in Gen Chem 2, we actually got the correct answer of something that was like 10 to the power 74. So yeah.
Yeah. Anyway, so that's the answer to the first question. The second question is, what is the density of the gaseous RC? And it's applying at the same temperature and pressure, so STP. So what is our equation again off the dome without looking at previous notes? Eyes up here. What's the equation? M over V equals. Well, we already used V.
For density
Yeah,
is P times molar mass over volume times that.
volume is used in the M over V part, right? RT, yeah, you were close though. You got the numerator.
Or PMAR, if you wanna remember that.
Yes.
PMAR, pressure times molar mass per RT.
So I'm gonna go ahead and squiggle out so we know we're working on part 2. So density equals P times molar mass over RT. This is equal to 1 atmosphere. The molar mass of gaseous RC ASH3 is 77.922 G per mole. And then we have the R is obviously a constant, so 0.0821. And then temperature is 273. This gives us a density of 3.48. And what is the units for density when we're talking about gaseous stuff all the time? What?
So what is your volume always in?
Liters. And what is mass always in chemistry?
Oh,
Grams per liter. You're probably guaranteed to see a problem like this on your test, asking about density of some gas or something. So if you really cannot solve these yet, then find more problems and keep working them out until it becomes like second nature. And that's honestly for this entire exam. I promise, like if you can't do the math, this exam will be really, really difficult. Okay, so practice as much as you can.
The exam, should we use 273.15 or does it matter?
It's not gonna change your answer a lot, and most of them will be multiple choice, and the multiple guess, like the free response ones,
They'll give you credit for a range.
like say, I mean, the 0.15 is gonna change your answer very little. So if the answer is 2.4, but the 0.15 in the 273.15 changes it to or whatever 0.45 instead of 0.4, then you're gonna get credit for that. But yeah, anyways, let's try number 25. This one is a nice one.
For the density of a noble gas, 2.71 grams per liter at 3 atmospheres and 0 degrees Celsius. Identify the gas. Pretty please.
I'm gonna do this one too. This is the one that I have, like, it took a long time, but there's an easier way to solve it. I just don't remember how often.
Dolphins look. Just always.
Because I remember Jake Kilbride last semester was like, oh wait, I just did this. What's that? Yes, to minus one. Multiply. How are you gonna find moles of this? Yeah, it's such an easy way to find pressure due to, so it's N over V equals P. Oh, that's the total pressure.
Which we did. in the first place.
Okay, so I think this will change. You did become total pressure first of all the gas. Or not the total pressure, the total amount of moles, and then just found the converted this to moles, and then just subtracted that. So what he did was P E equals and so we solve for RT. And then found N and then the total amount of moles of gas. Converted this to moles of gas. And then subtracted the total from this. Yeah, I haven't done it. So. What's the rate of the? 1 minute. Tell me the answer of the number answer you got. It's like hands. Davidson have a TA.
It's Ryan.
What?
I think it's Ryan. She was his TA last semester.
She leaves after basic.
Wait, Ryan, what's her last name?
I think it starts with a J.
Oh, she's not a TA, she's a star student.
She's only there, but she was always there for class.
Yeah, they get paid to go to class and watch.
Plus two down.
Be like even number.
76.
76 rows. Theater.
Do that, and I'm gonna do this. All right, so let's go ahead and start. What's the equation that we should be using in this scenario? You got it, the answer right. Let's help me out here.
V equals pressure equals one mass over R times temperature.
Over R times T. Why did she decide to use this? Well, probably because it gives us the density of the gas, and she knows that she has to have an equation that uses the density, right? So that makes sense. So this is exactly what came to her mind. Maybe not in the first second, but you know, she got it eventually. So that's all that matters. Or maybe she did get it off the dome, off the rip. I don't know. Anyways, it doesn't matter. So we know that it's asking for the identity of the gas. How would we go about finding the identity of the gas given this equation?
Gas on the periodic table.
I don't know if it's this computer, but it's super loud in my ear. I can't hear you.
Match the molar mass that you find
Yeah.
to the one on the periodic.
So she said she basically said the thing that can determine or identify a gas and is specific to that gas is its molar mass, right? So we know that we need to solve for molar mass. So it's going to be molar mass equals density times RT over pressure, which is equal to the variables we all have. So 3 atmospheres and 0 degrees Celsius must be converted to Kelvin. So 0 degrees Celsius is 273 Kelvin. So let me go ahead and drop this down. So plugging in everything we have 2.71 grams per liter. 0.0821. And 273 Kelvin. All over the pressure, which was 3 atmospheres. All right, let's put this in our calculator. We get that the molar mass is equal to 20.24 grams per mole. And we're done, right? Box in our answer, call it a day, move on to the next question. Why? Yeah, it's asking for the identity of the gas. The molar mass tells us, it doesn't tell us the identity of the gas, it tells us what the molar mass of the gas is. Okay, so we need to identify which gas it is. And if it's a noble gas, we should be looking at the group 18 on the very right of the periodic table. So doing so, we see something, any of those look familiar or close to that? Neon, exactly, Sydney. No way, my notability is updating as we speak. Leave the app for 1 second and they can't leave you, okay. Bruh. That's great. Perfect. This corresponds to yeah. Now we can box in our answer and call it a day. How was that problem? I know we did like 5 or maybe I'm overshooting that, maybe like 4 density problems today. So I hope by now you were able to use that equation to get the right answer. If not, keep doing some, and that's okay. So what is the verdict here? Was that the easiest one so far because you had the most practice, or was it just an easy question? Or maybe it was you're still struggling on it. How are we feeling?
Need the practice.
Yeah, it helped you, the practice? Good, I'm glad. All right, perfect. So this is what we will, let's find a question that we'll go over on. Okay, maybe not that. $26. Yeah, we can do 26. Well, how about this? We'll do 26, take a picture of it. And it'll be the first thing we go over on Monday. Just because this one's gonna take a little while and I want to be able to explain it. And I know we're at the end of our session and it's a really good problem. It's a really nice problem. So I'd rather have y'all have fresh minds next Monday before we go into this problem. Okay? So.
Can you send out the worksheet, please?
Rich, you gotta add your problem. I already added the other problems.
This is a general format of it. We can change up some.
Okay. All right. Well, I'm gonna go and stop the recording. If there's any questions, feel free to, we'll be here till like 3:30. That's when we end.